Now you must have fair idea on what is a shell, why we have so many shells, and why we have so many shells, and how do you compile a specific shell script, and why it is basically called a shell script, not a shell programming. So these are the fundamental things to understand. Like I told you in the last session as well. It's like English alphabets and English words. Using them, you form sentences and paragraphs. So basically, that's it. So, but from there, you can build like thousands and thousands of lines of shell script. You know, it's not about how fancy you write the shell script. It's about how easy you write the shell script. So, in my opinion, if someone writes a shell script, it should be in a position to easily understandable. You know, putting a pipe symbols and pipe symbol in each and every line, you know, elaborating a single line, it's in my opinion is not a great shell script, because it gives a hard time for someone coming in later and analyzing it. Okay. Now I'm sure we looked at this first script. What we were doing in this first script is nothing, you know, just a basic thing. If you look at these 5 commands like ls, pwd, sleep 5, clear, and echo statement. Echo statement is a statement that actually displays something on the screen, right? So we were putting all these commands in a single file, and we are calling that file as a 1.sh, and we are executing all these 5 commands as a single batch. There is alternative way of doing this. If I take you here, and what we were doing in this is we are doing 1.sh, we are saying ls, pwd, sleep 5, then clear, then echo. I am inside 1.sh, right? So how do we compile this? By default, even you are a owner, you don't have an execute privilege. But to execute anything, you need an execute privilege. It's like even if you want to enter into a directory, you need an execute privilege. So there are 2 ways you can do that. There are 2 ways you can give execute privilege. One is by just doing change mod user due to 1.sh. This is one way. Or there is another way is called like
44 or
44. Or if I keep the existing one 764. This is how you can even give it here. But this is the easiest one, so that we don't have to count what is the read plus write and what is read for group and others. Okay. So if I execute this as simple as 1.sh, if I type 1.sh, I'm getting the command not found. So any idea how we can fix this issue?
sh 1.sh.
Yeah.
Command. Okay. Yeah. One way is to one way is to just call the sh and 1.sh.
Yeah, that's one way. So what if I don't want to call it as that way? So
we'll have to update the first line with the shell. Oh, sorry. Can you open the 1.sh?
Let me write it here.
Yeah, right.
Bash. So if you do cat 1.sh, this is how I have. And when I say 1.sh, I'm still getting the command not found.
Okay.
So what do you think?
Okay, got it. The path need to.
That is true. The path does not basically have this current working directory. Now what do we have to do? We have to export path is equals to $path in colon. We have to say dot. So check in rest of all the directories. Before I do this, let's look at what is the path variable has the value. The way any executable will be picked up is it will be first checked in this directory. It won't be checked inside the subdirectories of this directory. It will only checked in this directory. For this 1.sh, it is not found. Then it goes here. then it goes here, here. Like this, it goes to each and every directory that is separated by colon here. Now what we have to explicitly say is we have to say export path equals to $path. Take the value of a path, this complete one, and put a semicolon and dot. What we are saying is take the current path and I am adding the dot at the end. Okay, so that means check all these directories. If it is not found, even check in this dot, means current working directory. So we are not saying what is that current working directory, right? We are indirectly saying that alias, that dot. So now if we say 1.sh, it will be picked up from the current working directory.
Okay, got it.
Now, so far good?
Yes.
There is another way of doing these commands. You can say ls semicolon pwd semicolon sleep 5 semicolon clear semicolon echo I am inside 1.sh. You can also execute all these 5 commands in a single line like this. But
yeah, got it.
Putting all of them in a script in a one file makes it much better readable file. So instead of just executing this from here, but here it's nothing. If you want to execute 2 commands from the command prompt which are independent, just put a semicolon and run it. Okay,
Got it.
That's what basically we learned from this first shell. And here the second shell script we have is basically this is of a job of a Unix admins to clean up stuff inside var log. Okay, so here we are writing a cleanup script. What this cleanup script is having is, of course we need to run it as a root, because root has only permissions to modify the files called messages and wtemp files. We are going to the directory called cd /var/log. Then we are assigning null value into these messages. Again we are assigning null value into this temporary. So these files will be cleared. And what we are saying is echo log files cleaned up. Then we are saying cd hyphen. You must know this difference between cd hyphen and cd. Cd hyphen will take you back to your previous working directory. It's like your previous channel in remote. Okay.
Yes.
Do you want me to show you this execution?
No, I think I'm okay. I'm okay with this one.
Okay.
So what I learned is the cd hyphen. He said it's like the previous directory.
Yeah, it's like a previous channel in remote. Okay.
Yeah, sure.
The next one is we were introduced in this with a new thing called comments in shell scripting. In shell scripting, there are no multi-line comments. The single line comment here is hash, with the only exception that hash bang for only one occurrence. Whenever it appears, the following lines will be executed in the respective executable that is placed here. So the following will be executed in a bash shell. Okay.
Okay.
So one important thing you need to understand here is, okay, before I explain you that, let me clear it. Let me type ps command. Right, we have 2 types of processes. Before I talk about processes, do you know the difference between process and a program? Basically, what is a process in your opinion?
What is a process? I mean, anything we run like a shell script and anything that we run execute does have a PID attached to it.
Right.
So process ID. I mean, the program eventually should have a process ID to run on the machine.
Yeah, a process is something in short called as a program in execution is a process.
Okay, okay.
A program in execution is called a process, as simple as that.
Okay.
So that means, for example, if I give you an example, ls is a program, when I say which ls, the ls is picked up from this directory called bin, right? This is just a process,
Oh,
just a program. But when I say ls and enter, this will become one source copy of this will be taken into a main memory, and a process ID is created for it.
okay, got it.
So, but ls stays as it is, but a copy of it from hard disk is brought into a main memory, and now ls functionality will be executed. So when that is happening, a program in execution is happening, we get a process ID for it. Similarly, when I say ps, you will see the current processes running in this system. Bash is one current process running in this terminal, and there is another process called ps. That means when I run the ps command, the ps is brought into a main memory RAM, and there is a process ID assigned to it. If I run ps again, the bash has the same process ID, but the ps this time will get a different process ID because this is another execution of a ps program. If I run ps again, basically what ps shows is ps shows all the processes started from this terminal only. So again, this time you get a separate process ID for this ps. When you do ps-f, you get a long listing basically, right? So this will give much
Right.
better idea. If you look at the first process that starts when you start a terminal, in your terminal is bash, whichever is the default shell. How can you find out your default shell? You know, you need to grab
Uh,
user ID in etc password. Whenever
okay.
someone requests for your user ID, for example, if I am joining in your team, you put a request for me saying, you know, Ravi join and create a user ID, user account on so and so servers. So along with that you put a request saying create as equivalent to my privileges as possible. So you know, if your default shell is bin bash, even I will get the same default shell. So that means whenever I open a terminal, if I open a terminal here, and if I log in with db2inst1, and if I say enter the password, the process that will be started from here is my default shell. Because bash is one executable. So bash is from bin bash. This will be running here and forever waiting for incoming connections, incoming requests. One such incoming request is ps-f. The moment ps-f comes, if you observe this bash process ID is 12198. It's like we all have parents, even these processes have parents. So this is invoked by a process ID called 12197. Now when something is running in this terminal ps-f, this guy is responsible going forward. So now 12198 becomes parent, and this will invite or invoke a process ID called 13279 and assigns it to this ps-f. If I run this ps-f again, basically the difference between ps and ps-f is f will give a full listing, much wider information than just a simple ps. If you look at the same thing stays as it is for this bash, but the ps-f this time 12198 brought up a different process ID for this execution. Okay. Now what happens when you execute a shell script is, okay, cat 1.sh. Okay. This will be executed inside bash. We are saying that 1.sh, right? There will be a process ID created for this. Okay. And what happens is, whatever the code inside this, there is one child shell opened and it will be executed in that child shell. For example, if your shell's process ID is 12198, there will be a new process ID opened. In fact, a new shell will be opened, child shell, and this will be executed in that child shell. Okay. What kind of a child shell will be opened? Because we have so many shells. We have like POSIX shell sh, we have a bash, we have a ksh, we have a csh, and if you look at these cat etc shells, we have all these types of shells. Now what type of shell that will be executed? is depends upon your first line. If you have a bin bash, or if you have any sharp and bang command followed by a shell name, this specific child shell is opened. Otherwise, whatever is your default shell, that will be opened.
Okay, sure.
Okay. Now, how can I see that? So if you go to 1.sh, and how can you display the process ID is echo $, and when I run ps-f, and if I sleep for like some time, if I run 1.sh, before that let me run ps-f. If I run 1.sh, if you look at 12197 and 12198, let me kill it here right away so that we can see it. This is before we are running 1.sh. When I am running 1.sh, the process ID is 13946. There is no such process ID here, 13946. But this 13946 is started by 12198. What is 12198? 12198 is this bash. That means this bash will open another bash.
Okay, right.
Okay. And it will execute this. Okay. So here is one important thing as well. Whatever the environment we specify in this bash, it won't by default come to this bash child shell. If you want, you need to export variables from here so that it will go to the child shells. There are two different commands in Unix environment. One is env, another one is set.
Okay.
You know the difference between both of them? One is env and another one is set. Okay. Okay, give it a try.
env is what it is currently set with the export when we did the earlier export path and all that.
Okay.
Set. Or at least whatever is in the dot profile, I think is what env.
Okay. Let's look at with an example. Now, when I do echo $Ravi, or let me say Rath, what I am getting is null, because there is no such variable as Rath, right?
Yes.
So I say RATH equals to fancy number 999. When I say echo $999, I'm sorry, echo $Rath.
Yeah.
Okay, you got this value. Okay, now when you do env and grep for Rath, there is nothing coming. But when you grep for in this set, you are getting a value. You are getting a hit.
Oh, I think I got it now. Is set for like the current session and env like for any session, every session?
Yeah. Now let me show you that. I want to hear it from you only. If I export Rath and if I run this env command, I can see it now.
Okay. Okay, so env set. Yeah, I do remember the usage of export, like when we wanted to say, example, a host name, we do that set as a host name and then do an export.
Oh.
But I'm unable to explain the difference between the env and set.
Now here is a difference. Env holds the environment variables that will be given to child.
Okay.
That means, there is a rule. I'm not sure how true it is with respect to the property inheritance in India. All the property that is hard earned by your grandparents has to by default go to grandchildren, even your father says no. See, if my father earned, let's say, 1 crore, he has an option not to give it to his children, give it to me or my sister. Okay, but if that property is inherited from my grandparents to my parents, then I have a right legally to get the same property. See what
Okay.
goes to the children. Here in this case, what actually goes to the child shells is everything you use it with export. In short, everything in the env will actually go to the child shell. Let me show you another example. So this time I say Ravi is equals to 99. Okay, and I'll open a shell called env.sh. I'll open a shell script. What I'm saying is echo the following line will print Ravi value. But when I say echo $Ravi, echo, did the print happen? Did you see Ravi value of Ravi variable? Okay, now let's test it out. So I said Ravi equal to 99. When I run this env.sh, change mode user plus x env.sh, what happens when I run this env.sh? Can I see the Ravi value? It came as a null.
Okay.
Because child, because what did we learn so far? When this environment env.sh file is running, it will open another child shell, right?
Yes.
So that child shell does not know about Ravi variable. But if I say echo $Ravi here, I have it. But when I run this env.sh, this Ravi is not known by this child shell because it's not part of env. So
Okay, got it.
if you want it in your child shell, just export this variable Ravi. So if I run this one.sh, now env.sh, I can see this 99 right now. So that's actually the difference between env and set command.
I have a question based on this.
Mm-hmm.
If I set the dot file and if I just do like a Ravi is equal to 99 and I don't do an export Ravi after that line and then I run few scripts,
Okay.
would that up then, or do I still have to do an export
Okay.
even in that dot profile?
Let's do this one more time. So what do you mean by dot profile? In your home directory,
Like,
there is a file called
yeah, whenever we in the profile, yeah, right. Yes.
va.bash profile. Okay. What do you do here?
Like generally, like yeah, like we set the DB2 to start working right away. If I add like say like a host name
Mm-hmm.
is equal to the host name in
Okay, let's take another variable. Like instead of Ravi, we say uh, let's say sum. Sum of values is like sum equal to 100.
okay,
Okay.
okay, sure.
Want me to set it this way and save and exit?
Yeah,
There is no export,
yeah, right,
right?
right. No export, correct.
Okay. Now let me open
So
another
if
terminal.
okay, sure, sure.
Now let me open another terminal, and I'm logging in as a DB2INST1. This time the sum will be sourced. Okay, some value is set. Now let's see. What do you want me to do now?
Okay. Sorry. Okay. Now in the script, like we can go to the env.sh or any other script one.sh. If I source the dot profile, the first line I'll call the dot profile.
Oh, I see your point. I see your. It will be picked up that time because you are explicitly
Oh, okay.
setting in that environment. Because here explicitly set up.
Okay. Huh. Yeah. Okay. Oh, okay. So here, just because we are calling it every time, it will pick it up. Is that what you meant to say?
Yeah. Since you are calling it here, it will be picked up.
Okay, got it. So it's more like writing sum in that script pretty much every time.
As
Okay.
yeah. env.sh. No, it hasn't picked up.
I think we didn't change it to sum.
Oh, okay, okay. Very good. Yeah, it picked up because every time, see, the shell will be prompted at the first line before you start working on the first line. So a new shell will be initiated here. Then this environment
Okay.
goes.
Okay. Okay. Got it.
Now,
Yeah, because I'm like,
now
yeah. Sorry. Go ahead.
let me modify sum as 199. And now let me run env.sh. You'll see only 100.
It, I think it should override it 100. Yeah.
It overrides because you're explicitly setting that.
Got it. Yeah. Okay. Yeah, like some scripts I saw export and some I didn't, so I had that doubt actually always. Somehow I didn't try to explore, but it worked both ways, but I was unsure as to why I was using export. So I
Okay.
think now it makes sense.
Okay. So it's basically the difference between env and set, what you can inherit to child shells and what you cannot. Perfect. Now let's go back to where we started. Okay, this is we are good, the comment. So in this example, the third example, third.sh, I'll be trying to introduce you to a concept called assigning the variables, declaring the variables basically. How do you store stuff, like some basically, we already looked at some, the same thing here. But the important thing here is, if you want to display the value of a fancy number, you have to use a character called dollar. You can read it as a dollar of a fancy underscore number, or alternatively you can say value of fancy underscore number. So my core number is colon value of fancy underscore number. It's a 999. The one important thing I want you to highlight from this is very loosely coupled programming. In short, it's a scripting, right? You don't have to declare or you don't have to define a variable before you actually use it. As long as you
Okay,
are
right.
not using shell keywords like uname, ls, pwd, okay, those stuff, you can use any of the variable of size you want. I think 128 bytes or something is the maximum size you can keep, but I'm not sure. I never cared about it because it's okay. So
Yeah.
all the things here are all these assignments are string assignments. Remember, this shell does not care about your variable types. Everything is a string in shell world. If everything is a string, how do we do arithmetic operation? Okay. So you want me to show you this example, or we are okay?
I'm okay with this one.
Okay. Now, in the next slide, what I have is a little improved cleanup script. I should have put it in a different slide. So here, since we got introduced to variables, I'm basically saying log under instead of just doing cd. If you look at my previous slide here, I'm saying cd /var/log. I just improved this script a little, saying here instead of directly doing cd /var/log, I'm assigning this log underscore dar as var log. I'm adding a comment here. Then I'm doing cd
Yeah.
log dar. I just add a little masala to it, one or two lines. And remember, I'm doing an exit statement here. Exit
Okay, right.
without any argument like exit 1 or exit 2. Exit always returns with 0. Exit 0 is nothing but 0 means success. Okay.
Yeah.
Let me take you here. So when I do cd hyphen, I'll go back. If I run env.sh, and if I want to see the return status of the previous execution or previous shell script, $?
Yeah. Right.
So 0 stands for previous command is successful. When you say ls and if you say echo $? 0 means it's successful. Okay. When you say grep asdf from etc, when you say grep db to inst1 from etc password, When you say echo dollar question marks, it means successful. But instead of that, if I give some characters that does not match, echo dollar question mark is a non-zero. In grep world, non-search result is unsuccessful. So we basically play on these return codes in shell scripts. The previous command is, if return code of a previous command is 0, then we proceed in one direction. Otherwise, we proceed with some error messages. We'll see them going forward. So that kind of an improvement I wanted to add going forward in these shell scripts. And here is actually the one I wanted to introduce. The one I wanted to introduce here is how do we do arithmetic? If in string everything is string, how do we do arithmetic? It's called using a command called expr. So there is a command called expr. What it takes is it takes two numbers and it will return the value. Okay, and basically what we are doing is we are calling this expr function inside shell script. So what we are explicitly specifying is there are two ways you can call this, and let's look at this commented way. Putting here reverse apostrophe, that means whatever you keep inside reverse apostrophe, this will be executed from the command line, the dollar form, and the result will be substituted here. You see my point? Let me show you this. Uname, right? Linux. When you say hname.sh host name, it's not a host name, host type.sh. When I say bin bash, where you say host type is equals to uname.
Yeah. Okay.
Host name equal to uname -n. So echo the host type is $h type. Echo the host name is $h name. You see what I'm trying to do here?
Yes.
So what we are saying is run this uname command from the command prompt and substitute the value here.
Yes.
Run this command from the command prompt. Whatever I am keeping it in reverse apostrophes. These are not a single quotes. These are reverse apostrophes on the left side of a one keyboard, on the keyboard.
Yes. Yes. Yes.
When change mode u plus x h type.sh. Now when you run h type.sh, you get the host type is Linux. Because uname is run, uname -n is run for the second one. Okay. If you want to see in a debugging way, you can say sh -x h type.sh. When you say just sh h type.sh, it will show you the same output as running with the executable permission. But when you say sh -x h type.sh, it will show you that this is the command that is getting executed, and this is the substitution that is happened. Then this is the command, this is the substitution, this is the command that is getting run, and this is the output. This is the command that is getting run, this is the output. You can see in a much bigger picture.
Yeah, for debugging, I think this mode will help.
Right.
Okay.
And there is another alternative way of debugging, since we brought that word. There is something called set-xv. When you do set-xv and just run command like this h type -sh, you don't have to run it with sh-x. If you enable set-xv,
okay,
what that will does is that we enable debugging at an entire script level. From that next line onwards, it will show you on the screen. H type is uname. Whatever it is. All the minute assignments and minute operations at that level, it will show you on the screen.
Okay, got it.
Yeah, uname is run, plus, h type, so on, so all these information. And one little flexibility with this is you can enable, and if you don't want to debug those statements, you can just say set plus xv.
Okay, got it.
You can take out this v, if you want. Xv gives the end-to-end information. So that means only debugging is enabled for these two lines.
Okay, got it. Yeah, if you need to like debug a subset of the entire script, I guess it makes sense.
Once in a while what happens is we know where the problem is, but we don't know exactly where the problem is. So
Right, right.
a
Yes,
function, or we only enable debugging for that function.
got it.
That is the challenge with this sh-x. sh-x enables the debugging for the entire file. But
Yeah, right.
yeah, but we need a solution that can enable it for only the code I want.
Okay, got it.
Okay. Now, so there is another way of running these, replacing these reverse apostrophes. If you don't like these reverse apostrophes, the equivalent way of doing it is put a dollar. This is another way of doing it.
Okay.
I mean, there are a number of ways to do things.
Yeah. Okay.
It has to come with practice. See,
Okay. Yeah. Right. Right. Exactly. Yeah.
come with.
I never use. I never know. I mean, I never knew till now that this even could work.
Okay.
I have used the other option you mentioned, the reverse
Reverse apostrophe.
codes, but I didn't know this would work. Okay, got it.
So I think this can be a nice example if I can add it. I mean, see, these are simple things, but it makes a huge difference. Like, it's not that fancy program I'll show in my class for like 200, 300 lines of programs. But I'll make sure you write the 200, 300 lines of programs with all this little knowledge. Okay.
Sure,
So
yeah.
we are good with this addition of two numbers, right? It's the same thing.
Yes.
So instead of calling uname, I'll call the expr function. What we are doing
Okay.
in our addition of these two numbers is we are manually assigning values to this number 1 and number 2. Instead of we manually assigning number 1 and number 2, don't we have any option to read it from the command prompt interactively? Yes, we have. The option is read command. Okay. So you say enter something on your screen and we say read. For example, let's modify this addition program. So if I add 2.sh, that means addition of two numbers, bin bash, I say echo enter first number, read number 1, echo enter second number, read number 2, sum total is equals to expr of dollar number 1 plus dollar number 2 echo dollar total. I mean, it's nothing fancy, the same thing. So what we do here is change mod user plus x add 2.sh. When I do add 2.sh, it is asking me to enter the first number. So I'll assign first number as 9, second number as 1, I'll get sum as 100. So here is a little I wanted to show you. Look at this, the read is reading in the next line. Let me run it again so that, the echo is displaying, then read is coming to the next line.
Yes, okay.
It looks much better if I enter here, right?
Okay, yeah, got it. Okay, right.
So for that, you have to say here echo hyphen n.
Yeah.
That means don't put a new line character. What happens is echo, whatever it displays, it puts a new line character here. That means it goes by default to a new line character, new line.
Okay.
So here it comes.
Yeah, looks better.
Sum is 0. Okay. Okay, so if you look at this add2.sh, we are reading two numbers, right? Initially in our first program, what we did was we looked at assigning the value, like number one is 100, number two is 200, like that. Later we looked at reading it from the command prompt interactively. Now there is a next level to it. It says what if I'm not available at system but I still have to pass certain arguments. That concept is called command line arguments in shell script, which is also called as positional parameters. What happens is, in the first example, like number one is X and number two is Y scenario, we are physically assigning it value, and every time you have to give a new values, you have to modify shell script. It is not good. In this example, this add2.sh, we have to physically present in front of a system to give the input again, which is not good. So what if I have an option where I can pass these values, whenever I'm calling this in front of a system. So that's where this concept of positional parameters came in picture. So when we run a shell script, that is during a process, the name of a program and the arguments supplied are stored in special variables called positional parameters. These positional parameters starts with $. For example, dollar is one kind of positional parameter. We looked at $, right, to get the right process ID.
Yeah.
The process, yes. $0 basically holds your name of the program. $1 to $9 holds your command line arguments you pass. $* is list of all arguments. $# is count of arguments. Let me quickly show you with this example. I add 2.sh. Let me modify this add program. Instead of reading these, so what do we do right now is number one equal to $1, number two equal to $2. Assign first argument as number one, second argument as number two. Okay, total is so and so. Now sum of given two numbers is, so you don't have to write here two, you can just say $#, the number of arguments. $# will be replaced with 2. Echo list of arguments is $. Echo
Process ID.
Yeah, name of the shell script is $0. Echo FPID is basically $. So when I run this at add2.sh, when I say add2.sh 199, say sum of given two numbers is 199, list of arguments is 199, and name of the shell script is add2.sh, and the process ID is 18481. Yeah. So you see this. This is how you can pass the arguments. If there is ever a need to pass, you can pass it this way. But here is a little trickiest thing. So we are good with this example so far.
Yeah, yeah.
So here we are only talking about passing 1 to 9. What if I have to pass a 10th argument? Okay, let's look at that example. I add, let me copy I add 2.sh. Let me modify this. Echo first argument is $1, second argument is $2, $9, 10th, replace 9, 10. Okay. So what we are saying is we're trying to print this first argument, second argument, 9th and 10th. So literally I'll pass now 10 arguments. Add 2.sh 10, 20, 30, 40, 12, 13, 14, 15, 16, 17, 18. So these are 5 arguments and these are 5 arguments, right? Now if I press enter, the sum of given 10 numbers, in fact it's not a 10 numbers, only it should be 2 because the R hash is coming as 10. So the
Yeah, 1 and 2.
interesting thing for me is first argument is 10, second argument is 20, ninth argument is 16, 10th argument is coming as 100. From where it is coming as 100? Okay.
You just pick 1 and 0.
Yeah, it just picks $10 and it assigns this as, it considered this way.
Yeah.
$1 is 10, then it appends 0 to it.
Okay.
Okay. So how do we avoid this problem? You know, is there any way I can hold the values outside 9, 10, 11, 12, 13? That's where we have a concept called shifting the arguments. So here you say number 9 equals to $9. Okay. Now what you can do here is you say I'll do the left shift 1. What happens when you do shift 1 is your 10th argument becomes 9th argument and 9th arguments become 8th arguments. First argument will be gone. You see, this is what happens when you do A, B, C, D, E, F, G, H, I, J. These are 10 characters. This is 1. So let me have it here 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. When I say shift 1, how it looks is B, C, D, E, F, G, H, I, J. This is how it looks. That means everything will be left shifted by 1.
Okay, okay.
So now what happens to A? It is gone. So before you actually shift, you have to physically literally store this in one of the local variables.
Okay, okay.
Makes sense, right?
Yeah,
Now,
yeah, yes.
if you do shift 2, two things are gone. A, B are gone. Now C occupies the first place. I mean, it's like awards. Hey, you have a rankings, right? 1, 2, 3. You know, first prize winner, second prize winner, and third prize winner. And when you are advancing from one level, contest, if you want to advance from level, you know, club level to next level, and your college level to next level, if number 1 and number 2 are not willing to participate, 3 becomes 1, right? 4 becomes 2, right? The same thing here. I am literally shifting by 1 position in the sense. Now 9th becomes 8th. So 10th becomes 9th here.
Okay, okay.
But you know, first argument will be gone. So you have to store this first argument in a local variable. So you say now the current first argument is $1. Let me sleep for.
Okay, okay.
You worry.
Okay. Yeah.
First argument is number 1.
But after the shift 1, second will be the 1 now, right? Like
Second will be the 1. Even though second will be the 1, it holds the $1 position.
okay, got it. Okay.
The same.
Okay, got it.
This,
So if we were to use
yeah.
$1 at point in the script, like you said, I will have to store it somewhere and call it again.
Like here, like at a number 1, we are storing it here.
Oh, okay.
Now,
Got it. Yeah.
if I run this,
Okay.
the 10th argument is coming as now 17. The current first argument is now 20. 20 here took the first place because this guy does not want to be in the first place. He rejected the offer. Now the original first argument, I still have it somewhere. I mean, it's a very rare thing that we use it, but you cannot avoid anything. Right? You cannot ignore, because this is a very good feature. Once in a while to a job, you might have to pass like 15, 20 different arguments. Because if you talk about server name or IP address or port number, database name, username, password, by default these are six are already gone. So once in a
Oh,
while you have to pass 12, 13 arguments to a specific script. So you cannot avoid it.
got it. Sure, sure.
Okay. So that's what I try to show it to you in these examples, and I'll email you this presentation so you can give it a try.
So in the above example, if I keep on like, if I just take one command line entry, oh no, not really. I was just thinking, so keep on doing shift 1, uh, and all I could do is read the first one always, but uh,
No,
no, I'm
what
sorry.
we do is, in reality, what do we do is, add to.sh, we simply shift by 9 characters. Now your 10th argument,
Okay,
first argument.
okay, okay,
Don't
okay.
generally take, because by the time you shift, you store all your variables here.
Yeah, okay, got it. Makes sense. Okay.
So we generally shift by 9. It's the simplest thing to do. So the same command line arguments example I'm showing it here. Like number one is $1 is first argument, $2 is second positional argument. And the scope of variables we have already covered. Same Ravi or Roth example. Some example. So same thing, you can give it a try in your meantime. So, and what I have next is conditional statements. Okay. What will be the ideal time for you to have this tomorrow, Ratnakar?